I was reminded, taking notes today. I'm a little behind. Sorry. Chapter 7. Lessons 6 and 7. Solving inequalities. Piece of cake today. Our central question, how, just not start with the W, how do we solve inequality? How do I solve an inequality? Oh, guy wrote I put we. We're in this together. This guy thinks you're on your own. I believe in teamwork, making the dream work. Whoops. Oh, okay. So, take some notes here. First we need to remember is how inequalities work. So there's 4 symbols involved. We have this one here, which means greater than. We have this other one, less than. And then these other ones, which we probably haven't seen as much. That is some hard math. Greater than or equal to. And our last one, you guessed it, less than or equal to. Anytime you want to read what we're doing, it's how you read those 4 symbols. And we're one little part of notes. When you, no, I didn't even say you, just say when graphing, sorry, when graphing. I could have read this. When graphing on a number line, graphing on, oh, this is a hard day for me. I use an open dot for less than or greater than. And close dot, or less than or equal to, greater than or equal to. It's Fernando. Hey, Fernando. Alright, so this is, when do we get to exponents pre-algebra? Later? Not entirely sure how pre-algebra orders things. So this is one of the 2 big things that's new. What we're doing is how to graph it on a number line. So we're going back to putting things on number lines. And then the other thing we'll get to in example number 5. Okay. We're not on example 5, we're on example 1. So what if we had an equation that said negative 16 is greater than or equal to y plus 8. So we're going to solve this like we did equations, only now it's not equal, now it's some numbers greater than or equal to something else. We still want to get our variable by itself, so we still want to get rid of this plus 8, so the opposite of adding 8 is to do minus 8. And whatever we do on one side of the inequality, we do on the other. So minus 8 on both sides. So the math part stays the same. 8 minus 8 still cancels out. 2 negatives, we combine them. This becomes negative 24. greater than or equal to y. Okay, so this is still just undo addition. Okay, so we jump right into how this is different here. So before, when we did equations, we said like negative 24, if that equals y, then y equals negative 24. No big deal which one comes where. But here, it matters. So if I want to rewrite this, I want to put y first. Okay. If I put y first, I need to flip this sign around. We say if negative 24 is greater than y, then y has to be less than or equal to negative 24. Okay. And then we're going to put this on a number line. So you're going to draw a number line best you can. Doesn't have to be perfect. I should have done fractions. No, man, fractions, that's too much. I like to keep it simple. We're going to put negative 24 right in the middle there. Put a couple extra numbers off to the side here so we can see what our number line looks like. Okay. We're going to put a dot on 24. Since it's less than or equal to, we said that's going to be a closed dot. Okay. And it's everything less than that, so it's all the numbers to the left. So if you're not sure which way to draw your arrow, it points the same way that our inequality sign points, assuming we put our variable on the left. So like this one points to the left, this arrow points to the left. It's like a helpful reminder. Or you can remember less than goes left, greater than goes right. That's the idea. Let's try a couple more, because maybe that wasn't clear. We've never done this before. Example 2. This one should have been example 1. It's just a lot easier. Thanks, Miss Geyer. Just kidding. She worked really hard. So h plus y is greater than 15. We want to get h by itself. So to get h by itself, we need to get rid of this plus 9. To get rid of plus 9, we do minus 9 on both sides. 9 minus 9 cancels out. Gives us h is greater than 15 minus 9 is 6. Our variable's already on the left-hand side, so we're good. I have done this before. Oh, okay. Easy. To make our number line, put 6 somewhere in the middle. A couple numbers bigger than 6 to the right. A couple numbers less than 6 to the left. Ha 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 ha. That shouldn't be 6. That should be 4. Okay. Since it's just greater than, this is going to be an open dot. And since it's greater than, it's all the numbers bigger than 6. So it points off to the right. And if you look, this one pointed to the right. This one pointed to the right. Not too bad. Not too bad. If you're good at equations, inequalities isn't difficult. Alright, example 3. Let's see. 8a is less than 72. So again, we want to get a by itself. So we need to get rid of this times 8. The opposite of times 8 is to divide by 8. We divide both sides by 8. 8s will cancel out. We get a is less than 72 divided by 8 is 9. I'm going to draw my a little bit better so you don't get a's and 9s confused. A and a 9. So let's plot this. Plot it. Let me go. Put it on number line. Well, it looks like Geyer got lazy with the number lines, which means I'm going to get lazy with my number lines. I'm just going to put 3 numbers on here. 8, 9, 10. It's just less than. So open circle. It's not equal to 9, so we're not including 9, but it's everything to the left of it. Okay? There's our answer. Our answer is both parts. This part and the graph. Example 4. Oh, here we go. Example 4. 5x minus 10 greater than or equal to 15. Now we have a two-step inequality. Oh boy, there we go. So same as before, we get rid of the plus or minus first. We get rid of minus 10, we do plus 10, both sides. Hopefully, after like a week and a half of this, you're getting good at solving equations. We have 5x greater than or equal to 15 plus 10 is 25. Then we're going to get rid of times 5 by doing divided by 5. 5 divided by 5 cancels out. Get x greater than or equal to 5. Okay, so if we're plotting this, not my best line. It's okay. There's 5, 6, 4. So greater than or equal to, which means we're including the number 5, so closed circle. Everything greater than that, so pointing to the right. There's our plot. 11 minutes. I think I told Fernando 12 or less. I don't think we're going to make it. It's close, though. Okay, example 5. So where it gets serious. Oh, I was supposed to put notes before that. Line before example 5. When you, or we, multiply or divide by a negative number, flip the symbol. And we'll explain why we do that after we finish the notes. Right now we're just taking notes. We're just going to say that's the way it is. Deal with it. But if you hang out after, we'll explain what's actually happening. Okay. So example 5. There's 2 more examples. Pretty boy. Yes, you only flip the sign if it's negative and you're multiplying and dividing. So plus or minus doesn't matter. Only multiplying and dividing. So x divided by 4 is greater than 7. Okay. That's our problem. So I want to get rid of dividing by negative 4. So the opposite of dividing is to multiply by negative 4. So I'm going to multiply both sides by negative 4. So these 2 will cancel out. We have x on the left. 7 times negative 4 is negative 28. And since what we multiplied by was a negative number, greater than is going to become less than. So our final answer here is x is less than negative 28. On our number line, ugh, our lines are getting worse. I can do better. Sort of. So negative 28, 8, it's an 8. Negative 27, negative 29. So just less than, open circle, not including that number, but everything to the left of it. That's our answer. Okay, one more. Example 6. I think is as hard as inequalities are going to get for us. A 2-step with a negative. We have negative 4x minus 13 less than or equal to 7. And so before you even start, you could probably identify, I'm multiplying by a negative number, so I know in the end I'm going to have to flip this sign. So I can even put somewhere down on the bottom. I know this is going to be greater than or equal to. Okay? Before I even do the math, I know that sign's going to flip. So let's do our first step. We need to get rid of minus 13. So we do plus 13. That's not a b, that's a 13. Okay? So this cancels out. So we have negative 4x. And technically speaking, the sign hasn't flipped yet, so we haven't multiplied or divided. That's less than or equal to 20. Okay? And then I need to get rid of times negative 4. So we're going to divide by -4. So those will cancel out. So get x, flip the sign, less than or equal to becomes greater than or equal to. 20 divided by -4 is -5. Positive divided by negative, always negative. Okay? It's not about the answer. Like, it didn't matter that both these answers were negative. It's the number that we divided and multiplied by that changes our sign. Okay? Nothing to do with the answer. Everything to do with how we got the answer. So -5, -4, -6. This is greater than or equal to. That's a closed circle pointing to the right. And there's your notes. Don't forget to write some questions. How do we solve two-step inequalities? How do we solve one-step inequalities? What are all of our inequality symbols called? And then a summary. Solving for inequalities is a lot like solving for equations, only there's no more equal signs. Good summary. And then draw a cat. So everybody likes cats. Give them whiskers. Some ears. Cat now. Alright, that's it for the notes. You can quit now. But I'm going to keep going. I like talking about it. So, we said we'd explain why does the sign flip. So let's say, how can we explain this? What if we said x greater than 6? We start with that as an example. So if I divide both sides by 2, I get x is greater than 3. Okay? So some possible answers. Ooh. Just any number greater than 3. So like 4, 5, or 100. Are you a teacher, Miss? Yes. My teacher name is Mr. Ellis. So if I try these, like if I just put that in place of x, is 2 times 4 greater than 6? It is. 8's greater than 6. No big deal. Is 2 times 5 greater than 6? Say, it is. And then 2 times 100. 200 is greater than 6. So this works. I simplified it. As long as I pick some number greater than 3, this original inequality will be true. Okay? But what if I change my inequality and some page? What if I said, how about -2x is greater than 6? Okay? So if I divide both sides by -2, okay? And actually, let's call this -6, just so we don't have to deal with picking negative answers. So this will cancel out. This gives us x, and then over here is 3. -6 divided by -2 is 3. Okay. The real Mr. Ellis, all one word. The. How are you? You're here. You're looking at the video. How do you not know the channel name? Oh well, I'll write it out for you. The real Mr. Ellis. No spaces, no caps, no periods, all letters, all the time. What are we doing? X and 3. We're not sure what this symbol is because we don't know what happens when we multiply negatives. We didn't take the notes. Alternate universe. So let's just pick some numbers around 3. Let's say, what if x is 2? What if x is, I don't know, 0? And what if x is 5? That's one less than 3, one that's 0, and one that's greater than 3. And let's put them back into our original inequality. So negative 2 times 2 greater than 6. Let's see, negative 2 times 0 greater than 6. And negative 2 times 5 greater than 6. Not all of these can be true, right? Because we know 3 is our important number. It's our key number where it's going to stop being true. Let's try it out. So negative 2 times 2 is negative 4. And is negative 4 greater than 6? Heck no. Negatives can't be bigger than positives. IK, but was it pronounced first or second option? Oh, is it there, Al, no, come on. That's just silly. Question was, do you pronounce it there, Al? So clever, sideways cat. No, it is not pronounced that way. That's as wrong as this answer here. Those are both equally wrong. Alright, what if we try this? What if x is 0? So negative 2 times 0 is 0. Is 0 greater than 6? No, it is not. Okay, none of these are right. What did I do wrong here? Oh, ooh. Okay, wait. I need to go back. No one corrected me. And I was looking at the chat. Because I changed this to negative 6. Hold on. Taking all this way. Shoot, now I just confused an entire generation of 7th graders. So is negative 4 greater than negative 6? Negative 4 greater than negative 6. I don't know. I'm so confused right now. This dog's looking at me. He wants to go on a walk. Let's make a number line. Here's 0. There's negative 1. Here's negative 2. Here's negative 3. Negative 4. Negative 5. Negative 6. Okay, negative 4. Negative 6. Which one's further to the right? It's negative 4. So this is actually, ha ha ha. I tricked you. This is true. Wait, what? I just bamboozled myself here? Okay, no, I'm good. Alright. Stay with me. Alright. Negative 2 times 0. I don't actually like inequalities. Much work. Negative 2 times 0 is 0. Is 0 greater than negative 6? And that's actually true. Okay, because here's 0 more than negative 6. And our last one is negative 10. Is negative 10 greater than negative 6? And this is the one that's not true. Negative 10 would be all the way over here. So if we look at it, which answers were correct? Were they the numbers more or less than 3? Okay, getting back on point here. So the answers that worked, 2 and 0, were both less than 3. So our correct answer here is x has to be less than 3. Okay? So what happened was our sign went from being greater than being less than. And that happened because we divided by a negative number. That was not a great explanation. My bad, because I messed up. I think Nameless Gamer threw me off. I want to say that's Mitchell. But I can't stay mad at Mitchell. So if we multiply or divide by a negative number, it's always going to flip the sign. Always. Okay? We'll practice more the next couple days. Okay. Good night.